9-2 homework problem number 17. The bullet in the previous problem strikes a 2.5 kilogram steel ball that is at rest. The bullet bounces backwards after its collision at a speed of 5.0 meters per second. How fast is the ball moving when the bullet bounces backwards? First off, we do need some information from the previous problem, number 16, mainly about the bullet. The bullet is initially 35.0 grams and is traveling at 475 meters per second. When we go to our problem, we see the bullet on the left, represented by the dash, has a mass of 35 grams and a velocity of 475 meters per second. It is moving towards a steel ball with a mass of 2.5 kilograms that is not moving, therefore at 0 meters per second. After the collision, the bullet has a mass of 35 grams and is moving backwards at 5 meters per second. The steel ball still has a mass of 2.5 kilograms and has an unknown velocity. That is what the problem is asking for. Our first step, before we continue on, is to change the mass of the bullet from grams to kilograms. There are 1,000 grams in 1 kilogram. Therefore, to change from grams to kilograms, we divide by 1,000, or simply move the decimal point 3 to the left. This gives us 0.035 kilograms. In this problem, we have a collision between a bullet and a ball. Collision in this case allows us to treat this as a conservation of momentum problem, meaning that the momentum before the collision, the momentum of both the bullet and the ball, is equal to the momentum after the collision, still the bullet and the ball. Before the collision means that we have P1 plus P2, P1 being the momentum of the bullet, P2 being the momentum of the ball. After the collision, we have P1 prime plus P2 prime. P1 still represents the momentum of the bullet, and P2 still represents momentum of the ball. The prime marker simply indicates that it is the momentum of each after the collision. Making our substitutions, we see M1V1 plus M2V2 is equal to M1V1 prime plus M2V2 prime. The mass in both cases did not get a prime marker, as the mass stays the same both before and after the collision. Substituting in what we know, M1V1 becomes 0.035 times 475, M2V2 becomes 2.5 times 0, M1V1 prime becomes 0.035 times negative 5, and M2V2 prime becomes 2.5 times V2 prime. Multiplying out what we know, 0.035 times 475 is 16.625. 2.5 times 0 is, 0. 0.035 times negative 5 is negative 0.175, and 2.5 kilograms times V2 prime is still 2.5 kilograms times V2 prime. The velocity of the bullet after the collision was negative 5 because it was traveling in the opposite direction. Now, continuing on our equation, to solve for V2 prime, our first step is to move the negative 0.175. We do this by adding it to both sides. Adding it on the right causes it to cancel out. Adding it to the left will give us 16.625 plus 0.175. When we add those two together, along with the 0, which is kind of unnecessary, we get 16.8 kilograms times meters per second, equal to 2.5 kilograms times V2 prime. The only thing we have left to do to isolate V2 prime now is to divide by 2.5 kilograms. Doing that on the right cancels out 2.5 kilograms. Doing that on the left gives us 6.72. Looking back at our original problem, we see that the original numbers we were given were 35.0, 475, 2.5, and 5.0. This means that we end up having a number of significant figures of 2, as there are only 2 significant figures in the 2.5 and 5.0. 6.72 will therefore round to 6.7. As we are solving for a velocity, it is measured in meters per second.